Hello my dear students, today we are going to study something about acceleration, a very important term related to motion. Let us go to our slide. First of all, let us see how do we define acceleration. What is acceleration? It is the change in velocity per unit time, or we can say that it is the rate of change of velocity. Okay, now according to this definition, we can make a formula for this. Acceleration is equal to change in velocity upon time taken, or we can see here A is equal to delta V upon delta T. Now what is delta V? It is change in velocity, and what is change in velocity? Final velocity minus initial velocity, and delta T is the time taken. Okay, now from the formula we can find out the SI unit. We know that unit of velocity is meter per second and that of time is second. So that makes meter per second divided by second, and we get meter per second square. So SI unit of acceleration is meter per second square, and it is a vector quantity. As velocity is a vector quantity, therefore acceleration should also be a vector quantity. That means it has both magnitude as well as direction. So now let us try to solve two questions related to acceleration. I have those questions ready with me. So let us look at the first question in this sheet. Average velocity of a particle moving in a straight line with constant acceleration a and initial velocity u in first t seconds is. Okay, let us try to solve this question on the slide. Now the situation is that there is a particle which is moving on a straight line, and it is given that its initial velocity is u and it has a uniform acceleration a, and let us say it moves for a time t, and in this interval we have to find its average velocity. This is the question, right? So now first of all, in junior classes we have studied that what is average velocity. It is total displacement upon total time. Suppose the total displacement during this interval is x and the time taken is t. So total displacement upon total time becomes x by t. Now also from what we have studied in junior classes, we know that the displacement in uniformly accelerated motion is equal to ut plus half at square. So we can replace the total displacement in t seconds by this, and let us divide it by t. So what do we get? U plus at by 2. Now let us see which option matches with this. U plus at by 2, option A. Now let us check the answers. Exactly, this option A is the correct answer to this question. So this is how we can solve the first question. I hope all of you must have understood the solution. Now let us go to the second question, again related to accelerated motion. During an accelerated motion of a particle, now option A, let us see whether option A is correct or not. Option A says average velocity of the particle is always less than its final velocity, right? Now this is not necessary. Average velocity may be more than the final velocity, because even a motion in which velocity is decreasing is also known as an accelerated motion, because according to the definition of acceleration, whenever there is a change in velocity with respect to time, then we say that the motion is accelerated. Now the change can be positive or negative. Even a decrease in velocity is a change, right? It has negative acceleration, but it has acceleration. So that means it is quite possible that the final velocity is less than the initial and obviously than the average velocity, right? For example, let us let us take an example to understand this option. Suppose a particle moves from here to here. Let us say its initial speed is 20 meters per second and it uniformly decelerates to a speed of 10 meters per second. If the deceleration is uniform, then for this interval the average velocity will be 15 meters per second, initial plus final by 2. Now this is more than the final velocity, right? So this shows that option A is clearly wrong. Now let us look at option B. Average velocity of a particle is always greater than its final velocity. Again, this is not necessary. Let us see on the screen how we can negate the second option. Suppose there is a particle with initial velocity of 10 meters per second and it accelerates uniformly to a speed of 20 meters per second. This time the speed is increasing. Now again in this case the average velocity is going to be 15, which is less than the final velocity. So it is not necessary that average velocity is more than the final velocity. So option B is also wrong. Now let us come to option C. Average velocity of the particle may be 0 also. Now this seems to be correct. Let us see how. Suppose a particle is moving along a circular path. Let us say it starts from here and moves with a constant speed. So at t is equal to 0, its initial velocity vector will look something like this, right? Now after a certain time, suppose it is here, so its velocity vector is going to be in this direction. After another some interval of time, the velocity will be in this direction. So we can see that the magnitude of velocity will remain constant as the speed is constant, but the direction keeps on changing. And whenever there is a change in velocity, the motion is said to be accelerated. So interestingly, a particle moving at a constant speed in a circular path is an accelerated particle. It is this motion is accelerated motion. Why? Because velocity is continuously changing. Okay, because acceleration is not rate of change of speed, but it is rate of change of velocity, and velocity is changing. Therefore, the motion is accelerated. Now, if we take an interval in which the particle completes one full revolution, then again it will be at the same point and it will have the same velocity. So in this interval, the average, which is defined as total change in velocity upon total time taken, and what is the change in velocity, final velocity minus initial velocity upon time taken. So since final velocity becomes exactly equal to initial velocity after one complete revolution, therefore the change in velocity becomes 0 and hence the acceleration becomes 0. So option C is the correct option, right? So we can tick mark the C option, but we should also check the D option. Average velocity of the particle is half its initial velocity. This is not necessary. This happens only if the acceleration is uniform. If it is uniformly changing, only then we can take the average velocity as initial velocity plus final velocity by 2. So the correct option must be option C, that the average velocity of the particle may be 0 also. Let us check whether this is right or not. So here we can see that answer to question number 2 is C. So it is the right answer. So today we studied acceleration and we did 2 questions based on accelerated motion. I hope you enjoyed the video. Okay, bye all of you.